So this is technically the second video, picking up right where we left off. We're going to be going over the homework, and it has all the questions I've been asking up until this point. Graph your exponential growth function, state the domain and range, and the y-intercept, and the asymptote. All right. So step one is to ignore h and k. Do we have an h or a k in this function? No, we don't. Okay. So let's think about the general form once again of an exponential growth or decay function. Y equals a parenthesis the base to the power of x minus h and then plus k. So we said there is no h or k. That's great. We could just focus in on graphing. We don't have to shift. Our xy table will provide our coordinates. Okay. Now the first thing to understand is that the b value is not -3. What's the b value? The b value is just 3. It's kind of confusing. It looks like the base is -3, but the base is not -3. Why is it not -3? Because there's no parentheses around the negative, including it. Okay, there is none. So the base is not -3. The base is actually 3. The a value is -1. Okay, so the first thing to do is to understand that this original function, exponential growth function, it's y equals -1 times 3 to the x power. Okay? And now we could jump straight into our xy table, and let's do consecutive integer inputs. So let's do a -3, a -2, a -1, a 0, a 1, a 2, a 3. By the way, we're not going to even use all of these. So which is the easiest one to plug in? 0. So let's think about this. 0 plugged in right to here, or into our new one, plugged in here, 0, that's going to give us 3 to the 0. What's 3 to the 0? 1. And what's 1 times -1? 1. -1. So our input 0 gave us an output of -1. And that is a coordinate. Now, we could continue to plug in 1. You want to do that just for funsies? Sure, why not? Plug in a 0 right there. I mean a 1 right there. What's 3 to the 1?
3.
And what's 3 times -1?
-3.
-3. Now, let me ask you this. I mean, that wasn't that difficult, but what's easier? Do that math process or simply go to the -1 and say, I need to make this grow by the growth factor of 3. What's -1 times 3? -3. What's the next one? -9. And what's the next one? -27, which is off the graph, right? So you see that growth factor. You could have, if you wanted to, plugged in 3 up here. I mean right here. And then 3 to the third. 3 times 3 times 3 is 27 times -1. It gives us -27. But it's easier to, once you have one output already, to just make it grow by that growth factor of 3. -1 times 3 is -3. Times 3 is -9. -27. Backwards would not be multiplying by 3. What would it be? Dividing by 3. Or, let's use the word multiplying. Multiplying by what? 1/3 is exactly right. So what would this next one be? If I go -1 times 1/3, what do I get? -1/3. Okay, sorry about that. Popular guy, get a lot of phone calls. Anyway, let's continue, guys. So if going this way, you're multiplying by that growth factor of 3, then going backwards is dividing by 3, but we're going to use the word multiply. It's multiplying by 1/3. So -9 times 1/3 is -3. -3 times 1/3 is -1. -1 times 1/3 is 1/3. What's -1/3 times 1/3? -1/9. Excellent. -1/9. -1/27. Excellent. Now, as you could see, it's getting smaller and smaller and smaller. It's infinitely approaching what? 0. But it'll never actually get to 0. It'll just keep getting smaller and smaller and smaller. It's kind of like Ant-Man, right? You guys ever watch the movie Ant-Man? No. Right? He keeps getting smaller, smaller, smaller. And then even though he's tiny, he could go into that quantum realm that's even smaller because he could keep shrinking. All right, maybe you haven't seen that movie. Anyway, let's graph these coordinates, guys. Let's plug in, or let's graph 0, -1. 0 on the x, -1 on the y is right there. And you know what? Yeah, I want to use red dots here because there is no h or k shift. These dots are my actual graph right here. Then I'm going to go to 1, negative 3. 1 on the x, negative 1, 2, 3 on the y. Then I'm going to go negative 2, or positive 2, negative 9. Positive 2, negative 9, way down here. And that's about it. I'm not going to graph 3, negative 27, because if I go 3 and I go negative 27, I'm going to be off this graph, way off the graph, right? Let's go backwards, though. Let's go negative 1 and negative 1/3. So check this out. If I go negative 1 on the x and negative third of the way down, that's not even half. Negative third is not even half. So I need to put a dot right there. And it's hard to draw a third of the way down, just as long as you don't put it halfway, because it's a little bit less than half, right? And then if I go negative 2 and negative 1/9, negative 2, negative 1/9, that's really close to 0. And we know that it's going to infinitely approach 0. And you're going to draw dots like if it's touching, but you know it never actually touches, just infinitely approaches. So visually, you could see your asymptote. Visually, what's your asymptote?
Going down.
It's definitely growing in a negative direction. If you're thinking, how could it possibly grow in a negative direction? Kind of like credit card debt. Your debt grows and grows and grows, but that means that you owe money, right? But in this direction, it infinitely approaches what? Y value of 0, right? And that is our asymptote. Our asymptote is this line. Our asymptote is y equals 0. Okay? Not only that, you could always know that your asymptote is y equals the k value. And if there is no h and there is no k, well then you could say that your k value is 0 and you know that your asymptote is y equals 0. Okay? So anyways, let's ask or answer other questions with regards to this graph. We didn't need to shift it up or down because we didn't have a k shift. How about what's our domain? Everybody should know the domain. The domain is what?
All real numbers.
X equals all real numbers. And it's important that you put x, right? Because domain are your x values. How about the range? The range are your y values. And your y values here of this red graph are either going to be above or below your asymptote. So is this graph above or below our asymptote? It's below. So what is the inequality that'll represent less than, right? It's below. So you're going to say y is less than your asymptote, which was 0. What else could we answer? We could say that the x-intercept or the y-intercept, what's the y-intercept? Where does it cross the y-axis? Where does it cross this y-axis? Right there. What is that location? 0, negative 1. So the y-intercept is 0, negative 1. We did that visually, or if you wanted to, you could do it algebraically. How do you find the y-intercept? You set x equal to 0. So plug in 0 right here, and 3 to the 0 is 1 with a negative in front. That will be negative 1 as your output. So that's about all you could say about this exponential growth function that's growing in a negative direction. By the way, what makes a function a growth function is that from left to right, it either grows in a positive direction, or from left to right, it grows in a negative direction. Okay, a growth function will either from left to right go to positive infinity or to negative infinity, right? A decay function, which we're going to be learning about and practicing tomorrow, it starts out at a huge value and it decays to a certain value. Again, a growth function from left to right, kind of like reading a sentence. A growth function will grow. A decay function will decay from left to right. Okay, how about you guys try number 2, which also does not have an h or k shift. Let's jump right into what? What's the first thing I should write right here when I start working on this? Okay, the input-output table, the XY table. Now, what kind of X values do I want? Do I just want to plug in whatever I want? 1, 2, 3.
0, 1, 2, 3.
0, 1, 2, 3. Now, if you're going to go start with 0, make sure you put it right here towards the middle. 0, 1, 2, 3. That way, you have space for the negatives. Okay? So up here, what do I put? Negative 1, negative 2, negative 3. And again, we're ignoring h and k. So you don't have, there is no h and k. So this is great because when I get these coordinates, I'll have my actual graph. So when I plug in 0, what's 3 to the 0? What's anything to the 0 power? 1. And what's 1/3 times 1? 1/3. So when I plug in 0, I get out a 1/3. Now that might seem a little weird. Now you could continue to plug in more values. All right? Do you want to, just for fun, plug in 1? Yeah? Okay, just for fun, let's plug in 1 right in here. What's 3 to the 1 power? And what's 3 times 1/3? That's 3 over 3, which is just 1, right? Now, I don't know about you guys, but I think it's easier to just look at this answer 1/3 and make it grow by 3. So 1/3 times 3 is 1. 1 times 3 is 3. 3 times 3 is 9. So it's a lot easier to use the growth factor as you're going down. So you're growing by 3. Okay, 1/3 times 3 is 1. 1 times 3 is 3. 3 times 3 is 9. Backwards, it would be dividing by 3. Dividing by 3. But instead of saying or using the word divide, let's use the word multiply. Backwards, it'd be multiplying 9 by what? 1/3. And 3 times 1/3 is 1. And 1 times 1/3 is 1/3. And 1/3 times 1/3 is? 1/3 times 1/3, 1/9. And 1/9 times 1/3? 1/27. And 1/27 times 1/3, it doesn't matter. It's already too big, right? I mean, not too big. It's too small. 1 over a huge number, it's just getting closer and closer to what? 0. So let's all graph 0 and 1/3. 0 on the x, 1/3 of the way up. It's not even halfway up, just 1/3 of the way up. Right there, not even halfway. And let's go to 1, 1. 1 on the x, 1 on the y, that's easy. Let's go to 2, 3. 2 on the x, 1, 2, 3 on the y, there it is. And let's go to 3, 9, 3, 9 way up here, there it is. So this is definitely a growth function in a positive direction. Why is it growing up? Because that was positive, 1/3. The a value is positive, which means from left to right it's going to grow in a positive direction. If it would have been negative, it'd be growing in a negative direction. But anyways, let's continue with these coordinates. And let's do -1 and 1/9. Okay, -1 on the x, 1/9 of the way up, that's even less than 1/3. So it's even closer to the x-axis. And then -2 and 1/27, that's practically 0. And we know that it keeps getting smaller and smaller and smaller, but we just draw the dots on the line. Even though we know it never touches, it just infinitely approaches. This is our asymptote, and you could visually say that the asymptote is what? Y equals 0. That's right, that's the asymptote. See, that red line will never actually touch the asymptote y equals 0, just infinitely approaches. So there is no h or k shift, so you don't need to move these coordinates anywhere. You just graph it. Let me graph it in blue to show those red dots that we have right there. You don't have to shift it up or down because there is no +3 or -3. You don't have to shift. There is no k value. So again, let's go through all the questions that we could, or all the statements we could say about this exponential growth function. The domain, what do we say? X equals all real numbers. How about the range? The range are your y values, and it's either above or below your asymptote. Y is greater than 0. It's above, right? This blue graph with the red dots, it's above the y value of 0, or yeah, the y value of 0. It's not below, it's above. Okay. What else could we say? What is the y-intercept? What is the y-intercept? 0, 1/3. 0, 1/3. Now you could see it right there visually, 0, 1/3. You can see it on the coordinate over here, 0, 1/3. Or you could even plug in 0 and get out the answer 1/3. What else? We already stated the asymptote, domain, range, y-intercept. I think we're done. We're good. So we need to continue with number 3. And what should I do on this one that's different than the previous 2? Sophia, what do you say? What's different of this one from the previous 2? It has a k value, right? So we're going to ignore that k value for a little while. I want to put a little square right here on top of it. I want to ignore it. Or on your paper, what I would do is draw a box ignoring that k value. So don't cover it up, don't scratch it out. You're gonna use that 5 later. I'm just gonna ignore it for now. I box in what I'm gonna make an XY table for. Okay? And let's use consecutive integer inputs. So it's going to be -3, -2, -1, 0, 1, 2, 3. Let's plug in the easiest number, 0. Plug in 0 right there. What's 2 to the 0?
0.
What's anything to the 0?
0.
1. Anything to the 0 power is 1. So what is 1? What is 1 times -1/2? What's 1 times -1/2? -1/2. Come on, guys. Anything times 1 is the same value. Okay? So I could continue to plug in a 1 right there and work out all this math. I could plug in a 2 right there, work out all this math. I could plug in a -3, work out all this math. But that's honestly a waste of time if you already know that this is a growth function in a negative direction, and it's going to be growing by what factor? 2. It's going to be growing by 2. So from here, from this output of -1/2 to the next one, I need to make it grow by 2. So I need to say -1/2 times 2. What is -1/2 times 2? If you want, do it on a calculator. When you do -1/2 times 2, you're going to get -1. And when you get -1 and multiply it by that growth factor of 2, what are you going to get on the next one? -2. And when you multiply that by 2, it's going to be -4. Now we could go to the next coordinate, which would be a 4 and what? What would be the next one? -8, right? Because the growth factor is 2 times 2 times 2 times 2. The next one would be -16, but that's already off the graph. That's why I'm not going to use it. It's not 6, it's -8, because you're multiplying by the growth factor of 2. Okay? Now let's go in the opposite direction. If I am multiplying by 2, going backwards, I'd be dividing by 2, but let's use the word multiply. What -8 times what gives me 4? Half. Times half is 2. Times half is -1. Times half is -1/2. Times half, what would that be? -1/4. Times half. What's -1/4 times half? -1/8. Times half? -1/16. Okay, and we know that it's getting smaller and smaller and smaller, closer to 0. Now, not only that, guys, can't you see the symmetry here? Look at 1, 2, 4, 8. Look at the denominators. 1, 2, 4, 8. There's even patterns right there within the pattern. All right, guys, so let's graph these parent graph coordinates. So let's go to the coordinate 0 and -1/2. 0, -1/2 would be right here, not even all the way down, it's just halfway down. And then let's plug in 1 and go to -1. So 1 on the x, -1 on the y. Now let's go 2 on the x, -2 on the y. Let's go 3 on the x, -4 on the y. And 4 on the x and -8 on the y. Now as we go to the negative direction on the x values, if I go -1 and -4, -1 and then -4, that's half of the half. This was halfway down. -4 is half of that. So it would be right here. Now at that point, it's too hard to draw anything any closer. You're going to draw, we know it's 1/8, 1/16, -1/16, -1/32, -1/64, -1/128. But we know that it looks like it touches, but it doesn't touch, it just infinitely approaches. Now, it would be nice if we'd be done, but we're not. Why not? Because we still have this k value. We still have this k value of 5 to deal with. So the k value is your shift, either up or down. So what am I going to be doing with all these coordinates? Shifting them where? 5 up. So you're going to take this one and go 1, 2, 3, 4, 5 and put a dot right there. I'm going to do my new dot in red. And then this one, 5 up, 1, 2, 3, 4, 5. The next one, 5 up, 1, 2, 3, 4, 5. The next one, 5 up, will be right there. The next one there, and so on and so on. Now, I also highly recommend start with your parent graph asymptote and move that asymptote 5 up. That way you know where your line is going to end up. It's going to end up right there. And what is the asymptote? Asymptote is y equals your k value, which happens to be 5. So we know that way up here on this line, y equals 5, your red line will infinitely approach it but never actually touch it. So there's your graph. You might as well connect all the dots here. Now the original coordinates were from our parent graph. So you don't want to represent that graph. I would put 2 x's on it just so when I grade your quiz or test, I know that the blue one is not the one you wanted to represent. It's this red one that had the final shift of 5 up. Okay, now then we could go through and say, okay, domain of this red exponential growth function in a negative direction. The domain's all real numbers. The range is y is above or below the asymptote. Actually, let me write down what I'm writing here. The domain, x equals all real numbers. The range, y is what? Above or below? Less than what? Y is less than 5. Because your asymptote was at 5, and this whole graph is below 5. And that's about it. That's all you could say. I want to stop this video right here. It's pretty long. I'll do another video explaining the rest.